You've heard of green hydrogen. You've heard of blue hydrogen. But what about white hydrogen, the kind that comes straight from the Earth? As of 2025, over 40 active natural hydrogen projects are underway across the world, from commercial production in Mali to deep drilling in the US and Australia. This could be one of the biggest energy discoveries of our time, and it's happening quietly beneath our feet. Let's explore where natural hydrogen is being found, who's leading the race, and why this could reshape the global energy landscape. Natural hydrogen, also called white hydrogen, is hydrogen gas that forms naturally in the Earth's crust through chemical reactions between water and iron-rich rocks. Unlike green hydrogen, it doesn't require electricity or water electrolysis. It just exists, often trapped underground, waiting to be tapped like natural gas. And the best part? It could offer clean, continuous hydrogen production without the huge energy costs of manufacturing it artificially. That's why geologists, startups, and even oil giants are now racing to find it. Our story begins in Africa, the birthplace of commercial natural hydrogen. In Mali, a small village called Burakebugu has quietly made history. Since 2012, the Burakebugu project, run by Petroma, has produced about 5 tons of hydrogen every year from a single natural well. It's the world's first and only commercial natural hydrogen operation, and it's powered the local community for over a decade. Now, other African nations are joining in. Tanzania's Rukwa Basin, initially explored for helium, recently confirmed viable hydrogen traces. And in Morocco, early surveys are combining geothermal and hydrogen exploration to assess the country's underground potential. Africa may have lit the match for what's now becoming a global energy race. Across the Atlantic, North America is moving fast. In the United States, the companies Hytera and Natural Hydrogen Energy LLC are drilling deep in Kansas and Nebraska, exploring more than 72,000 acres under what's called the Namaha Project. Hydrogen concentrations there have reached as high as 92%. That's incredibly pure gas. Meanwhile, Koloma, backed by Bill Gates' Breakthrough Energy Ventures, is drilling hydrogen wells in Arizona, Minnesota, and Nevada with positive early results. And in Canada, geological teams are scanning Quebec and Ontario, searching for hydrogen-rich ultramafic rock formations. The Canadian government and mining firms are funding these efforts, seeing hydrogen as the next big clean export. North America's advantage? It already has the infrastructure and investment appetite to scale discoveries fast. Next stop, South America, where discoveries are just beginning to emerge. In Colombia, scientists confirmed a high-concentration hydrogen find in the Nariño Basin in 2025. The government is now courting private partners for a pilot extraction program. Further south, in Brazil, geological teams led by the National Research Agency CPRM are exploring the Ceará Basin, hoping to identify natural hydrogen reserves along the northeast coast. For resource-rich nations like these, natural hydrogen could become a new export pillar, just like oil, but without the emissions. Europe is taking a more scientific but equally ambitious approach. In France, startup 45-8 Energy is leading the Lorraine Basin and Pyrenees White Hydrogen Program. France now holds Europe's largest confirmed natural hydrogen reserves, with exploration licenses granted in mid-2025. In Spain, drilling in the Castilla region, where early tests have revealed hydrogen traces. And in Albania, the Bulkaze field confirmed subsurface hydrogen in 2024, with feasibility studies underway. Even the United Kingdom is getting involved. The Royal Society recently highlighted Scotland and Cornwall as potential hotspots, but regulations for hydrogen exploration are still catching up. Europe's strategy is clear: build the knowledge base first, then scale safely once the data proves it's viable. In the Asia-Pacific, Australia and India are making big moves. In South Australia, a company called Gold Hydrogen struck hydrogen concentrations above 90% at its Kingston SE site. By 2025, the firm had received multiple government exploration licenses, signaling official support for commercial-scale testing. In India, a geological survey identified 4 hydrogen-rich zones stretching from Ladakh to Gujarat. Pilot drilling is expected to begin in 2026, part of India's strategy to reduce fossil fuel imports. Meanwhile, in Turkey, scientists are testing volcanic and ophiolitic structures in central Anatolia, areas believed to be emitting natural hydrogen gas. The region's mix of volcanic and mineral-rich geology makes it one of the most promising unexplored frontiers for natural hydrogen discovery. So what makes all this so exciting? If natural hydrogen can be extracted safely and economically, it could offer a constant renewable supply of clean fuel without the huge costs of green hydrogen production. That means lower energy prices, less dependency on fossil fuels, and a massive leap forward for countries aiming for net zero emissions. Major investors are already paying attention. From Bill Gates' breakthrough energy ventures to national geological agencies, everyone wants an early foothold in this new energy frontier. But it's still early days. Most natural hydrogen projects are in the mapping and pilot stage. The key challenges now are developing exploration technology, building regulations, and proving long-term sustainability. Still, the pace is accelerating fast. Mali, France, the US, and Australia have already demonstrated real-world hydrogen extraction. If successful, commercial natural hydrogen production could expand across multiple continents within the next 5 to 10 years. We might soon see a world where hydrogen wells stand beside oil wells, but this time they power the clean energy revolution. So next time you hear about hydrogen, remember, it's not just being made in factories, it's being discovered deep underground. The natural hydrogen rush has begun.
Across the world, we're at a critical moment in time due to rising temperatures related to climate change. And this is forcing a reckoning and an exploration of alternative energy sources. Natural hydrogen is one of them. I'm Barbara Sherwood-Lawler, and I'm a professor of earth sciences at the University of Toronto in Canada. There's already a long-standing global hydrogen economy, but it's driven by hydrogen that's produced by industrial processes. And we refer to this as green or blue hydrogen. The focus of this report is on naturally occurring hydrogen that's accumulated in the crust. In this sense, then, it's also distinguished from what is referred to sometimes as geologic or stimulated hydrogen, which is another approach under research that looks to try to accelerate or anthropogenically produce hydrogen from the rocks. In this report, we're looking at places where the Earth has already done that for us and where that natural hydrogen is accumulating. It's early days for investigation of the commercial viability. At this point, there's several major parameters that are being researched by scientists all over the world. That is to understand the depth and accessibility, to estimate the volume of hydrogen that may accumulate, and in particular to understand the purity of hydrogen that may be available in these deposits. But the calculations in terms of theoretical yield of hydrogen tell us that even if a small amount of this can be harnessed for commercial use, this may be part of our solution to achieve net zero, to achieve a green energy transition, and to address the ever-pressing necessities enforced upon us by climate change.